Welcome to Learning with Philemon. The periodic table is present in most science classrooms around the world, as well as on many t-shirts and coffee mugs. Unfortunately, because students cannot often interpret it, the periodic table becomes an imposing decoration rather than a useful tool. My hope is that these next few videos will help you feel more confident when using a periodic table. There have been many versions of the periodic table, as scientists discovered elements and tried to organize them in a logical manner. If you are interested in the history of the periodic table, please check the description for a list of scientists, such as Lavoisier, Dobereiner, and Mendeleev, that have contributed to its development. The modern periodic table, as we see here, contains all the known elements we have discovered. Each element is represented by a chemical symbol. This consists of either one or two letters. The first letter is always capitalized and the second letter is always lowercase. For example, hydrogen is represented by the capital letter H, and helium is represented by capital H and lowercase e. These are two examples where the letters used for the chemical symbol match the names of the elements in English. However, there are cases where the symbol comes from the name of the element in another language. For example, potassium is represented by a capital K, not a capital P, because in Latin the element was called kalium. In some periodic tables, the full name of the element is written underneath. You will also find two numbers around the chemical symbol for each element. The atomic number tells us the number of protons in the nucleus of an atom of that element. For example, lithium has an atomic number of 3, which means lithium atoms always have 3 protons in their nuclei. The elements in the modern periodic table are organized in terms of increasing atomic number from left to right, as you can see here, 3, 4, 5, 6, and so on. They are also organized in columns and rows, as we will see later in the video. An atom always has the same number of protons and electrons, so the atomic number also indirectly tells us the number of electrons in an atom. Lithium has 3 protons and 3 electrons. The most common isotope of lithium has 4 neutrons as well. Different isotopes of the same element have the same number of protons but different number of neutrons. For more on calculating the number of neutrons, watch the atomic structure video. If an atom gains or loses electrons, then we form an ion. For more on this, please watch the ionic bonding video. The second number we see is the relative atomic mass. Remember that the majority of the mass in an atom comes from the protons and the neutrons in the nucleus. The value is relative because the mass of each element is actually compared to the mass of 1/12 of the mass of a carbon atom. To calculate the relative atomic mass, a weighted average of all the naturally occurring isotopes is taken. For more on this, please watch the isotopes video. Because an average is taken, you will see some decimal points in relative atomic masses. In this periodic table provided for GCSE exams, most relative atomic masses are actually rounded. It can be confusing because the relative atomic mass is not always found on the bottom, and the atomic number is not always found at the top of a periodic table. This depends on the periodic table. To avoid confusion, remember that the atomic number will always be the smaller of the two numbers. Elements can be split into different types: metals, metalloids, and nonmetals. Metals are found on the left-hand side of the periodic table. Pause the video and see if you can find a metal that you recognize. You could have chosen an element such as lithium, iron, or gold. Most elements are in fact metals. Nonmetals are found on the right-hand side of the periodic table. Pause the video and see if you can find a nonmetal that you recognize. You could have chosen an element such as carbon, oxygen, chlorine, or neon. Metalloids have properties of both metals and nonmetals, and are found in between. A good way to remember which elements these are is to draw this staircase. The elements within, like silicon and arsenic, are metalloids. Elements to the left are metals, and elements to the right are nonmetals. Apart from being ordered in terms of increasing atomic number, the elements are also ordered in rows and columns. A row in the periodic table is called a period. A column in the periodic table is called a group. Can you find the element in group 14 and period 5? Pause the video. The element in group 14, period 5, is tin, Sn. Students often get confused because they do not count the first period, which only contains two elements, hydrogen and helium. Elements in a period have their valence electrons in the same energy level. Valence electrons are the electrons in the outermost shell or energy level. Both lithium and beryllium have their valence electrons on the second shell or energy level. I will discuss this in more detail in the IB and A-level videos. All the elements in the same group have the same number of valence electrons. For example, all elements in group 1 have one electron in their valence shell. We can see this for lithium and sodium. For more on this, please watch the electronic structure video. Because chemical properties are determined by the number of valence electrons, elements in a group have similar chemical properties. This is very important because if we know that one element reacts in a certain way, then we can expect the rest of the elements in the group to react in a similar way. We will see this in subsequent videos. Note that although hydrogen has only one valence electron, it's not always placed in group 1 because its chemical properties differ from the rest of the elements. Thank you for listening. To practice these concepts, check out the worksheets on my Patreon page. If you want to support my channel, check the donation link in the description. If you haven't already, please subscribe to my channel to get notifications for new videos. Stay curious.